In this video, we're going to cover subqueries. And there are two classifications of subqueries we're going to cover. One's called a scalar subquery and one's called an inline view. And in a scalar subquery, we're taking basically, we're creating a dynamic column. We're writing best way to think of it is we're writing a function but with an inline query. So I want to start off with this statement, but I want you to ignore what I'm highlighting. And over here I'm saying let's select the user ID, the first name and the last name from users, and I'm aliasing the user table as you. And we all should know at that point what we're going to get. We're going to get all the users from the users table and the user ID and the first name and the last name. Now let's look at what I have highlighted. I have open parentheses, select count star from user email as UE, where ue.userid equals u.userid, end parenthesis. And then I say as email count. And again, it's above the from. What I'm actually doing is getting the count of emails for whichever user we're looking at from user ID. So we're basically taking the user ID from users out here and putting it into here and running this query. Now when I run this, it takes a moment. We get all 175,000 users, but we get a number here. And it's usually either a 1, maybe a 0, maybe a 2. And these are the number of emails this person has. One way to think of this, it's kind of interchangeable if we were writing a function. And what I mean is, for what's between the parentheses here, could we write a function, or imagine there was a function, called email count, that we would pass it a user ID and it would return the number of how many emails we have. We're doing that, but we're basically writing it as a query. The reason why this is called a scalar subquery is we're creating a column dynamically. We're not necessarily changing the number of rows. We're not. We're just grabbing a single column. One of the bad things about running your queries like this is that for every row returned from the users table, this query has to run once. Meaning, for this unique ID, user ID, the first one, cults, we had to run this query replacing u.userid with that value. Then we had to do the same thing for Abel and Connor and Rose and Cameron and Axel. So essentially we ran 175,370 queries in 1.9 milliseconds. Overall, it is a much more inefficient way. There are much better ways to do this, but we're going to start with this because it is the easiest one to write. Here's another example I have where I'm selecting the user ID, the first name and the last name from users. And this query is selecting an email. It doesn't necessarily select multiple emails because obviously users can have several emails. It's just going to return one email per person. And if it doesn't find it, it's just going to return a null. So if you see here, what we get is a couple of emails for Colt and Abel here, but Connor doesn't have an email, so we get a null, and the same thing for Rose. Remember, null is that absence of data. So that's why we get those nulls. I did say that these scalar subqueries are a lot like functions. And just like functions, they have to return a single value. That's why I have the limit here of 1. If I was to remove the limit of 1, then what we're trying to do is fit multiple values coming back from this query into one row. And what's going to happen is it's going to error. It's going to say the subquery is returning more than one row. That's why we have to have a limit in there in order to ensure that the subquery is only returning one row. Here's another example, and I kind of made it a little more complex. I threw in a having clause. And let's go ahead and start from the beginning. We're going to select the DVD ID and the DVD title, and then some type of query, subquery from DVD. having copy count greater than 0. If you recall, I said we can only use having, or we should only use having, on dynamically created columns. Well, this subquery is what makes up copy count. Therefore, it's not a column in the DVD table. It is dynamically generated, and we should have it in the having. And then I say order by the copy count descending. Well, what is this copy count? We're going to get the count of user DVDs, so how many times this DVD is owned by someone, where user DVD.dvdid equals DVD.dvdid. So for every DVD we look at, we're going to get the count of how many people own it. And this takes a little bit to run, but we can see that the 1962 Beverly Hillbillies Volume 1, there's 14 of them. And there's a couple of 14s and then 13, so it is ordering it correctly. The important thing to know about the scalar subquery is it's kind of like a function. And if this was a function, what would be the argument? What would be that parameter? Meaning, if I was going to call a function, what do I have to pass it in order to get my data back? And in this case, I'd have to give it a DVD ID to return a number of how many people own that DVD. Just like up in here, I would have to pass the function a user ID before it could tell me how many emails that user has. I have to identify the user first. So in that case, it's kind of like an argument. And this leads into my next classification. For scalar subqueries, there's two subtypes. One's called correlated and one's called non-correlated. And I want to show you both of them here together. And what non-correlated means, correlated is just a big word. I like to relate it to connected. Is the subquery connected or reliant upon which row we're looking at? So is it related to the outside table? And if I run this, I'm getting the item ID in the title from item, so we get those two. And then over here, we're getting the average retail price from item. If you notice, it doesn't change. That's because if this was a function, select the average retail price from item, I don't have to pass it an argument. There would be no argument. It would just be get me the average retail price of every item I have. That's why this amount here is unchanged regardless of which row I look at. This value is not dependent upon which ID we're looking at. Therefore, it's not connected, it's not correlated. However, this one, which is from above, where we get the count of their emails, is based on which user we're looking at. If I run it, this column email count changes based on which user ID we're looking at. So because this u.userid is coming from a table outside of the parentheses, it's correlated, it's connected. If this was a function, I would have to pass it the user ID to get the count of emails for that user. As opposed to up here, this is an independent SQL statement. Another test you can do is highlight the statement and then run it. If it runs, it's not connected, it's not correlated. If I select this and I hit run, it's going to give me an error. And the reason is it doesn't know what u.userid is. It doesn't know what this is. Until I run it, the entire thing as a whole. Now it knows because we're connecting the inner and the outer. So inside scalar subqueries, let's go back to the slides for a moment. There are correlated and non-correlated. The pros for scalar subqueries is that they're fairly easy to write. The problem is they do have, the more rows you look at, the more times that inner statement is running. So performance-wise, it's not the best. However, there is another statement we can use, or another subquery we can use, called an inline view. And I want to start off by running this statement. We're going to select the user ID and the count from orders, and we're grouping it by that user ID. And we get the user ID and then the count here. Well, wouldn't it be nice if we could take these results and then treat them as a table so we can join against it? Basically, wouldn't it be nice to create a temporary table to join against? And what we can do is I took this statement here and just pasted it right here. And watch what I did. I'm going to select the user ID, the first name, the last name, and order count. Order count is going to be the same order count that's up in here. So we're going to get from users, and I'm aliasing that as you. And I'm going to left join it against this, and I call it OC. So now, anytime I talk about OC, these are the results I'm talking about, 18,019 rows. Whenever I talk about you, I'm talking about users. Now, if I'm left joining, remember what that means. We're getting all of the rows from users, and then we're joining it over to OC. So even though I have 18,000 users with emails and their counts, we have 175,000 users. So a lot of them are not going to match up, but we're still going to get back every user. But anyway, because we're doing a left join, you still need to have your on condition. So we're doing OC, which is the subquery, .userid equals u.userid. And the reason why we want you in there is we want their first name and last name, as opposed to over here, we're just getting the user ID and the count. Now watch what happens when I run this. And this one does take a little while to run. I'm just going to stop it for now. We should probably go in here, and I'm just going to put a limit of like, oh, I don't know, 1,000. We're getting everything from the users table. So you see someone like Colts, Trinks. The order count is blank. That means he doesn't have any emails. Any orders. We're going against orders here. I apologize if I said emails. But if we start scrolling down, what we'll see here is Faith has one order because we're selecting this from the orders table. I'm sorry, I think I said emails previously. Luke here has one. And Carter and Ian here, they have one. Easiest way as you're writing this to think about it is to grab this query and run it. And now think of it as a table called OC, and then join against it as you would a normal table. The good news, or the best part about this, is it's a little more complex to write, but performance-wise, this select statement now runs once. It gets put into memory and it's treated as a virtual table, as opposed to the scalar subquery, where the inner query gets run once for every row returned from the outside query. And I put a few examples here in the slides. Let's see that again. I go over correlated and non-correlated. Okay, and that's what we have for subqueries.